This screencast is to help you understand how to use exponents that have integers as opposed to just regular positive numbers like we saw earlier in the semester. This is a chart showing all the properties of integer exponents. It should look familiar because it's the same one we used earlier in the semester with positive exponents. But now this is going to apply to even when n or m are negative as well. The first one is product of two powers. That's whenever you have two like bases, we add the exponents. Second one is power of a power, where exponents get multiplied. Third one is the distributive property of exponents. Fourth one just gives information about how to do a fraction raised to an exponent. And then the fifth one we're going to focus on here first. This is when you have a quotient, you're going to subtract the exponents. So let's just start with some examples just to kind of motivate the new part we're going to talk about today. First one, x to the fifth over x squared. These are divided, so it's a quotient of two powers. That means you need to subtract the exponents. So this answer is going to be x to the third. Okay, moving on to the next one. Now we have x to the fifth over x to the fifth. Still quotient. When you subtract the two exponents, we get x to the 0. This is pretty new. We need to figure out exactly what this is. So just for a second here, let me actually write this out. We have 5 x's on the top and 5 x's on the bottom. All right, what happened was every single x canceled or reduced to 1, which means the answer to this is 1. And you probably knew that before. Anytime you have a number in the numerator over the same number in the denominator, that equals 1. In order to make this property work, we're going to have to make a definition, a mathematical definition, that x to the 0 has to equal 1. This will apply to any number raised to the 0 power, not just x, any number at all. We'll come back to that later. The last one is to motivate negative exponents, because whenever we subtract 5 minus 7, this one becomes x to the negative 2. Here, if I write it out again, 5 x's in the numerator and 7 x's in the denominator. Again, a lot of them reduce, 5 of them to be exact, but then I have x squared left over in the denominator. That gives us the definition of a negative exponent. It just means take the reciprocal of it. So x to the negative 2 is the same thing as 1 over x squared. Let's take a look at some of these properties now, just so you can get this down, and we'll look at additional examples that involve all of these properties. So here's the first one, exponent of 0. Just quickly, some examples I mentioned before. Anything to the 0 power is 1. 1. Here we have variables, doesn't matter, still equal to 1. The negative exponent property, or definition, says that if n's a positive integer, then we say that b to the negative n equals 1 over b to the positive n. Let's take a look at those examples just so you can see what they look like. That means x to the negative 5 is actually equivalent to 1 over x to the 5th. 2 to the negative 4 is the same thing as 1 over 2 to the 4th, which reduces to 1/16. So all I'm doing is taking the reciprocal and changing the sign of the exponent. This one, 10 to the negative 2. That's the same thing as 1 over 10 squared, or 1 over 100. And finally, just something a little strange, 2 over x to the negative 3. We have to take the reciprocal of x to the negative 3, which in essence is just going to move it to the numerator. So it switches positions, and it comes up to the top as a positive 3. The 2 is going to stay there because it didn't have any exponent or anything. It's just a regular number. Okay, let's look at some of these examples of just plain numbers, again, just for practice. Try these yourself. So push pause, see how you do, and then go ahead and play it again just to check your work. Okay, you should have had 1 over 2 cubed, or 1/8, 1 over 10 to the first, or 1/10. And then finally on this one, we're using power to a power. 3 times -1 is -3, so this is equivalent to 1 over 5 cubed, or 1 over 1/25. All right, now move over to additional examples with variables. Again, just trying to make use of those same properties we did earlier in the semester. Now, probably going to have some negative exponents as results. All right, the first one. Those are like bases added. So I'm going to go ahead and add them, like bases that are multiplied. So I'm going to add the exponents. That becomes x to the -3. In math, whenever we're asked to simplify these types of expressions, you're going to simplify without a negative exponent. So even though x to the -3 is the answer, it's not the simplified answer. We're going to go one step forward and actually put that in the denominator. So the simplified answer would be 1 over x cubed. All right, the next one. This is power to a power, so I'm going to multiply the exponents. Here again, there's a negative value. So even though that's the answer, I have to take one more step and write it without the negative exponent on the bottom. Okay, another one. This is making use of the distributive property of exponents. So the square is going to get raised to the -4 power, and so is the y cubed. Let me write out the steps just to show you what it looks like. So this would be equivalent to x to the -8, because I'm multiplying, times y to the 12th. Here again, this is not simplified. The x to the -8 needs to be in the denominator. Y to the 12th is going to stay right where it is. There's nothing wrong with it. It's a positive exponent. So it will stay on top. You can write it two different ways. You could write it as 1 over x to the 8th times y to the 12th. Or the more preferred method is just to combine those together as y to the 12th all over x to the 8th. So the 8 goes to the bottom, the x to the 8th goes to the bottom, y to the 12th stays at the top. Okay, and last example is just an additional one with a number that's there in front. Here we have like bases, so I'm going to add the exponents. The 3 just sits there in front. Here again, we have a negative answer as the result, so I'm going to change it so that it's in the denominator. 3 stays up there because it's a regular number. So the solution is 3 over a squared. We'll make use of this actual section a lot in the class. Nothing specific, but it'll come up in various sections where we need to simplify. So practice and go ahead and complete the assignment for section 5.1.